As we approach the winter of 2025-2026, anticipation is building among scientists and weather enthusiasts alike. The world is watching, waiting to see what the coming months will bring, especially as unusual signals begin to emerge from far-off corners of the globe. Meteorologists are closely watching a powerful signal from the Indian Ocean, a region that often holds the key to understanding global weather shifts. Teams of experts are poring over data, searching for clues that might reveal what lies ahead. The Indian Ocean Dipole, or IOD, has plunged into a record-breaking negative phase, reaching -1.94, stronger than the positive events of 2019 and 2023. This is a rare and significant development, one that has captured the attention of climate scientists worldwide. In a negative IOD, cold water pools near Africa while warm water builds near Australia, creating a dramatic temperature contrast. This imbalance in ocean temperatures is not just a local phenomenon, it has the power to influence weather thousands of miles away. This contrast sends atmospheric waves rippling across the globe, disrupting weather patterns far from their source. These waves can alter rainfall, shift storm tracks, and even change the timing of seasonal weather events. Such a strong anomaly acts like a tuning fork, influencing the jet stream and even the polar vortex. The jet stream, a fast-moving ribbon of air high above the Earth, can be nudged off course, leading to unexpected weather in distant regions. A negative IOD is often linked to a weaker polar vortex, increasing the odds of cold air outbreaks in North America and Europe. When the polar vortex weakens, frigid Arctic air can spill southward, bringing sudden and severe winter weather. While not a guarantee of a cold winter, this is a major clue that the global weather engine is primed for disruption. The atmosphere is more sensitive to disturbances, and even small changes can have outsized effects. The record-breaking nature of this event suggests its influence could be especially significant this season. Past negative IODs have been linked to extreme weather, and this one is already setting new benchmarks. Understanding this signal is crucial. It frames the rest of our winter forecast. By decoding the patterns in the Indian Ocean, scientists hope to provide better guidance for communities preparing for the months ahead. That's why all eyes are on this distant ocean phenomenon. Its story is just beginning, and its impact may be felt around the world as winter unfolds. How can warm water near Australia affect a snowstorm in New York, or even a cold snap in London? It might sound far-fetched, but the answer reveals just how astonishingly connected our planet's weather truly is. Imagine a blizzard swirling through Manhattan, or icy wind sweeping across London's streets. These dramatic weather events can actually be traced back to changes thousands of miles away, over the vast Indian Ocean. The answer lies in the atmosphere's interconnectedness. Weather isn't just local, it's a global conversation, with signals and energy constantly exchanged between oceans and continents. When the Indian Ocean experiences a negative Indian Ocean Dipole, or IOD, it fuels massive thunderstorms, pumping heat and moisture high into the atmosphere. This isn't just a local event, it's the spark that can ignite a chain reaction across the globe. This surge of energy creates atmospheric ripples called Rossby waves. These waves travel vast distances, warping the jet stream's path and setting off a cascade of weather changes far from their origin. When the jet stream is nudged, it can open the door for cold air to surge into new regions, transforming mild autumns into sudden, biting winters. Looking at past years with a strong negative IOD, we often see a mild November in North America, with people enjoying unseasonably warm days and late autumn colors. But then, almost overnight, there's a dramatic flip to cold in December, a sudden arrival of winter that catches many off guard. In Europe, the cold pattern tends to arrive even sooner and often lingers longer, bringing extended periods of snow and chill to cities and countryside alike. The key takeaway? Earth's climate is deeply interconnected. A major event like a record-negative IOD can set off a domino effect, driving dramatic weather shifts across continents and oceans. The energy released in the Indian Ocean can telephone the polar regions, setting the stage for a volatile and unpredictable winter, even in places far from the tropics. This is the first major domino in a complex sequence we're tracking, a signal that echoes through the atmosphere, shaping the season ahead. The signal is clear. Distant oceans can shape our winter, reminding us that no matter where we live, we're all part of a single, dynamic planetary system. The negative IOD's influence on North America unfolds in a fascinating sequence, shaping the continent's weather in ways that are both subtle and dramatic. This powerful climate pattern, originating far away in the Indian Ocean, sets off a chain reaction that ultimately determines how winter will play out across Canada and the United States. November often starts off surprisingly mild, with gentle temperatures and calm conditions as the atmosphere gradually adjusts to the shifting global patterns. But while much of North America enjoys this temporary reprieve, a different story is unfolding farther north. High pressure quietly builds over the Arctic and northern Canada, creating a vast, invisible dome over the landscape. This lid acts like a cap, trapping frigid air beneath it. Over time, the cold intensifies, pooling in the darkness of the Canadian wilderness. The sun barely rises, and the land radiates its heat away, allowing the cold to deepen and settle undisturbed for weeks. By early December, this storehouse of cold has grown immense, a vast reservoir of Arctic air just waiting for the right moment to escape. The trigger is often a sudden shift in the jet stream, which acts as a gatekeeper for the cold. When the jet stream buckles and plunges southward, it opens the floodgates. Arctic air surges deep into the United States, colliding with warmer air masses and igniting powerful winter storms, blizzards, and dramatic temperature drops across the continent. This two-step process, a deceptively mild November followed by a sudden intense December freeze, is a classic signature of strong negative IOD years. It's a pattern that meteorologists watch for, knowing it can mean a winter of extremes. The IOD's role is crucial. It helps set up the high-latitude blocking needed to build this cold reservoir, orchestrating the atmospheric conditions that allow cold to accumulate and persist over northern Canada. Without this setup, the cold might never have a chance to build. Winters would be milder, with less snow and fewer dramatic storms. And the landscape would look very different. Bare, green, and thawed, even in the heart of winter. That's why watching developments over Canada in the coming weeks is so important. Meteorologists closely monitor satellite images, weather stations, and atmospheric models to anticipate when and how the cold will be released. The stage is set for a dramatic winter shift, one that could bring intense cold, powerful storms, and a true taste of Arctic winter to millions across North America. While the IOD sets the background, the Madden-Julian Oscillation, or MJO, adds short-term variability. The MJO is a moving pulse of tropical thunderstorms that circles the globe every 30 to 60 days, passing through phases that influence mid-latitude weather. Forecasts show the MJO moving into phases 6 and 7 in November, critical for Europe. In these phases, the MJO encourages high pressure to build over Iceland and Greenland, creating a classic blocking pattern. This block disrupts the usual mild westerly flow, opening the door for much colder air. The MJO acts as a trigger, working with the IOD to set up high-latitude blocks. Its progression is a key piece of evidence for a colder pattern, especially in Europe. The timing of the MJO could be the spark that ignites winter. A Greenland block, high pressure over Greenland, is a game-changer for European winters. It deflects the jet stream south, blocking mild Atlantic air and allowing Arctic or Siberian air to surge in. Northerly winds bring frigid Arctic air. Easterly winds unleash the beast from the east, from Siberia. The MJO's move into phases 6 and 7, combined with a negative IOD, makes this block more likely. A weak, wavy polar vortex further supports these stubborn high-pressure domes. If the Greenland block develops, as models suggest, Europe could see an early, harsh start to winter. This is how distant climate drivers become real-world cold. Meteorologists use the Arctic Oscillation, AO, and North Atlantic Oscillation, NAO, to track large-scale pressure patterns. In their positive phase, strong low pressure over the Arctic keeps cold air locked up, leading to mild winters. But both AO and NAO are forecast to flip strongly negative by mid-November. A negative phase means high pressure in the Arctic, aka the Greenland block, pushing frigid air south. The NAO specifically tracks pressure between Iceland and the Azores. A negative NAO means high pressure near Greenland, blocking the Atlantic jet stream. The MJO and negative IOD are driving this shift, making the atmosphere more prone to cold-friendly patterns. The forecasted negative AO and NAO confirm a major pattern change is likely. The entire northern hemisphere circulation is shifting toward cold. Even with strong climate signals, Forecasting weeks ahead is tricky, especially when models disagree. The American GFS model shows a warm early December for Europe, with high pressure keeping cold at bay. In contrast, the European ECMWF model predicts a classic cold pattern high pressure near Greenland, jet stream diving south, and Arctic air flooding Europe. The ECMWF aligns with the IOD MJO and expected negative AO/NAO, suggesting a decisive turn to winter. This model split highlights the uncertainty in long-range forecasts. Many meteorologists favor the ECMWF's colder outlook, but the GFS's warmth is a reminder to stay alert. The outcome isn't guaranteed. Close monitoring is essential. The next few weeks will reveal which model has the better handle. Recent weather offers clues about the atmosphere's shifting state. October 2025 was the UK's third dullest on record, breaking a long streak of sunny high-pressure months. This shift to cloudier, unsettled weather hints at a broader pattern change. Past strong positive IOD years led to mild winters. Now, with a record negative IOD, the odds favor the opposite. The dull October suggests the old pattern is breaking down, priming the atmosphere for bigger changes. Combined with the MJO and model forecasts, these clues build a compelling case for a colder winter. The atmosphere is already showing signs of a shift. So, what does all this mean? We're facing a winter with a much higher chance of prolonged, widespread cold than in recent years, a record negative IOD, a timely MJO phase, and models forecasting a negative AO/NAO all point to a memorable winter. For North America, expect a mild November, then a surge of Arctic cold in December. For Europe, the shift to cold could be more immediate and sustained, especially if the Greenland block develops. Uncertainty remains. Model disagreements remind us that nothing is guaranteed. We'll need to watch for the Greenland block and AO/NAO shifts as definitive signs. Understanding these patterns helps everyone prepare, from governments to the public. The signals are clear. The atmosphere is primed for a significant shift. Now we watch and wait to see how powerfully this winter will unfold. One thing's certain, it's shaping up to be a fascinating season.